important. You start with this one, and then there is going to be another one in the coming sections. As I talked about it the other day, chain rule is your main tool for differentiation. Okay, so what we did with the chain rule, the function is going to be a complicated function. It's going to be a composition of two functions, even more. And if you want to differentiate those composition of function, so we just differentiate each function and then we multiply them together. Okay, so we gave you two versions of the chain rule. You see this is the first version. So the first version is that in short, we have a composition of two functions. You see you have the u function inside and the g function outside. So if you want to find the derivative of this function, it's going to be the derivative of the outside, g prime of u times the derivative of the inside. So for example, today, you may think about the g to be sine function. So if you want to find the derivative of a sine u, it's going to be the derivative of a sine, which is cosine of u times u prime. Okay, whatever it is inside the sine. So this is one version that we're going to use today. But the way we used it the other day and most of the time is that if this g is a power function, so if the g is just something raised to the n, that something, of course, going to be a function, a parenthesis. So we apply the same formula. So the action of the outside is the power rule, nu to the n minus 1, and the inside one would be u prime. So we focus on this one the other day, and we give you something like 4 different cases, and we end up with the 2 cases only. Okay, so that was the first one. The one that I'm going to do today is I'm going to use this formula for the time being for the trigonometric functions. Later on, we are going to use it for the exponential function and the natural log function. And at the end of the course, we are going to come back to it again. We're going to use it for the derivative of the inverse functions. Okay, so let's see what is going to be the chain rule and the trigonometric functions. Okay, so this is going to be, so we continue in that section. This is again part of that section 2.4 that we started the other day. Okay, so there you are. So we want to know what's going to be the relationship between trigonometric function and the chain rule. So this is it, and the chain rule application, or chain rule and okay, and trigonometric function. Trigonometric, how can you use it? Metric functions. So we're going to focusing on the derivative of the these functions. Okay, are you ready? So let's recall what you know about the derivative of the trigonometric function and how we're going to bring relate them to the chain rule. And so recall that what you know. You see, recall that we know the following. You see, the first part is derivative of the sine function. Sine of x is cosine of x. That's the first thing that we know, and we use it so far. Number two, we know the derivative of a cosine of x, which is going to be negative sine x. That's number two. Number three, we know derivative of a tangent of x, okay, which is going to be equal to the secant square of x. Okay, and the fourth one, you know, these 4 functions that we focus on. Derivative of a secant of x. Derivative of a secant of x would be secant of x times tangent of x. Secant tan. You know, the other one cosecant, cotan are going to be the same. So this is what we know so far. You see, they are just a function, single function. Okay. Now what we're going to do is we are going to compose this sine function with something else, not x. You may have sine of x squared. If you get a sine of x squared, so you have two functions. Outside function is sine, inside function is x squared. Then you want to differentiate it. Okay, so this is going to be the one. Now we bring the chain rule. So these are going to be the, so this is the one we know. Okay, and by the chain rule, and this is by the chain rule. You see, this is what we are going to apply. If you want to find the derivative of a g of u, g outside u inside prime is going to be the derivative of the outside, g prime of u times u prime, a composition of two functions. So what you are going to have for this group that you're going to have. So by the chain rule, we are going to have, okay, we conclude that, what's going to be that for function that we got over there. You see, this is what you're going to get now. So the first one becomes, if you want to find the derivative of sine of u, sine of x squared, sine of radical x, okay, sine of the 2x, sine of the 5x, pi x. So now this is a composition of two functions. You see, g is sine. The outside function is sine, inside function is u. So if you want to differentiate it now, you focus on the derivative of the outside. Outside derivative of the sine, cosine of u. You better put it inside the parentheses to know that you're going to operate it twice. So that would be the derivative of the outside function times the derivative of the inside function. Inside function is u. So the derivative of u would be u prime. You see, that's going to be the chain rule version of the sine function. Any question? So that's case one. Case two. So the case two, if you want to find the derivative of a cosine, not x, anything else, you call it u prime. So g is cosine. G prime would be negative sine times u prime. So the derivative of the outside, negative sine u times the derivative of the inside again, u prime. Okay, so that would be change your version of the cosine function. Now the third one, how about the derivative of a tangent of something other than the x, tangent of u? Again, your g function is tangent. The derivative of a tan, secant squared. But remember, it's a secant square of u. But you have to multiply by the derivative of the outside, u prime. Okay, same thing for the secant. Number four, what is going to be the derivative of a secant of u? Derivative of secant of u, outside is secant. So the derivative of a secant is secant tan. Secant of u, tangent of u, but you have to multiply by the derivative of the outside, which is u prime. That's it. That's a chain rule version or application of the chain rule to the trigonometric functions. Any question? So this is how we're going to do it. Of course, in this case, u is okay. So these are going to be all true when or where, okay, where u is a differentiable function, is a differentiable, okay, is going to be a differentiable function of x, okay, like x squared, radical x, pi x, depends where you are. So that would be our first version. Any question? So we need 4 examples to take care of it. It's very popular. It's going to be used quite a lot in various applications. And as we go on through the different courses in calculus, we are going to use them quite a lot. So expect 1 question of this on your next quiz at the end of the week or on Monday. So example, We wanted to find the derivative of each function. Find the derivative okay, of each function, There you are. Easy case if you just follow the rules. The first one. The first example is going to be the function is f of x equal to the sine of x cubed. You see, it's not sine x, it's sine x cubed. So it's a composition of two functions. The outside function is sine, the inside function is x cubed. So you have to apply this one now. So the chain rule derivative would be derivative of the outside, derivative of a sine, cosine of x cubed, times that by the derivative of the inside, u prime. U prime derivative of x cubed would be 3x squared. You see, you can remind yourself that, oh, this is u. Okay, so for the solution, you remind yourself that you are interested in the derivative of a sine u. Just repeat the formula for you. So it's going to be the derivative of the outside cosine of u times the derivative of the inside u prime. You see, if it's going to be x, you don't need it because u prime is 1. But it's going to be anything other than x, you have to multiply by derivative of that function inside. So there you are. The answer is going to be f prime of x is equal to derivative of the sine, cosine. But remember, the angle is going to be the same, cosine of x cubed, but times it by, put it inside parentheses to make sure you remember that you have to multiply by u prime. U prime derivative of the x cubed, which is going to be times it by 3x squared. But remember, monomials up in front. So you have to switch it, or you can do it right at the beginning. But the final answer is f prime of x equal to the 3x squared cosine of x cubed. This is the way you write it down. Any question? So we don't usually leave it as is because we don't be confused between this x cube and the 3x squared, because 3x squared is kind of monomial, or it's going to be a coefficient, then cosine of the x cube. So that's the case one. Any question? So you see outside, derivative of outside cosine, but cosine of x cube times derivative of the inside, 3x squared, done. No simplification other than switching that monomials are going to be possible. Okay, that's the case with the sine. The second one, case with the, okay, case with the cosine. Okay, there you are. I have the case with the tangent. I do the tangent first, and I go back to the cosine. This example is going to be very popular. It's going to be used quite a lot. Tangent of a radical x. Let's say that's one. This radical x is popular. Sine of radical x, cosine of radical x, secant of radical x. This is going to use quite a lot. So that's why we bring it up, so that you know how to deal with this one. Okay, then it's a composition of two functions. The outside function is tangent. The inside function is radical x. So you have to use the chain rule formula for the n. So you can remind yourself, if you like, that you have to use the formula of tangent of u. The derivative of tangent of u, derivative of the outside, if of a secant, tangent is a secant squared of u, but we have to pay for it, u prime. You see, because it's not x. If it's x, it's done. It's a u, so we have to multiply by u prime. Okay, so we are going to copy that formula. So h prime of x, you see, h prime of x is going to be equal to, and that's it, derivative of a tangent secant squared. But remember, it's a secant square of u, radical x, times it by the derivative of the radical x. Okay, I've already talked about it when we go to the trigonometric function. You better memorize this one, that derivative of radical x is 1 over 2 radical x. Okay, that would be popular to write it down in this form. Remember, this is it, the radical x. We switch it into the x to the half. Okay, so the derivative of radical x would be 1/2 of x to the negative 1/2. And if you simplify it, so that give you 1 over 2x to the half, which is 1 over 2 radical x. Okay, so when when it's used for the trigonometric function, simply derivative of radical x is 1 over 2 radical x. If you even write this on, we give you the point, but you better get to know this this version because it's going to be used in applications in future. Okay, we are not done. We have to move the monomial up in front. So h prime of x, the final answer is going to be 1, okay, over 2 radical x, 1 over 2 radical x times it by secant squared of radical x. We don't usually rationalize it. We just leave it as is. Okay, any question? So if you just keep it in order, really, it's going to be nicely done. So that's with the tangent. So let's have an example with the secant. Okay, are you done? Let's go to the next page and bring the secant case. So number 3 is going to be, this is going to be number 3. Number 3, the case with the secant. So something like f of x equal to, okay, 6 times secant, okay, secant of the 5x. This is the secant case. This 6 is a constant, is a number, just keep it. So we have a secant of the 5x. So again, it's a composition of two functions, because this is 5 times x, it's not just x. So derivative of the outside, you keep the 6. 6 times derivative of a secant. Derivative of a secant is tangent secant tan times derivative of the u. U is 5x, derivative would be u prime. Okay, so there you are. This is going to be your solution. You can remind yourself that this is going to be your u this time. Okay, so you can remind yourself, if you like, the formula that you're going to use is secant. You know that the secant of u prime is going to be the derivative of a secant, which is secant u. Secant of u times tangent of u. That's the derivative of the outside function times the u prime, derivative of the inside function. Okay, just copy the formula. So f prime of x is going to be equal to 6 is the number, 6 times it by derivative of a secant tan, secant of 5x. Remember, the angle is going to be the same, u. Secant of 5x, tangent of 5x. But you have to multiply by u prime. What's going to be u prime? Derivative of 5x is just 5. Okay, this 6 is a coefficient. You just carry the coefficient. If you have a secant tangent, but you have to pay for it, u prime. U is 5x, so u prime would be 5, but you have monomials here. You see, you have one monomial 5 and the 6. We talk about it. You have to move it forward, bring it up here, and then simplify it. So your final answer is going to be f prime of x is going to be 5 times 6, 30. 30, secant of 5x, tangent of 5x. So that gives you the final answer. Okay, any question? So that's case with the secant. I should give you one with the cosine. Now, one with the cosine. You see the cosine is this case, something, when you are in physics. So you may have to deal with this type of problems, 5, okay, cosine. Okay, you may have 5 cosine of the, let's say, 2 pi x. When you are in physics, there are some formulas when you study something like, electrical circuit, etc., or the wave functions. So you may have something like 2 pi x, pi half x, different format of the angles that you're going to have. Then you may have to differentiate it. So again, this is the case for the chain rule, because it's a composition of 2 functions. The outside function is cosine, the inside function is 2 pi x. So you remind yourself that you have to use the cosine version of a chain rule. So derivative of a cosine of u is going to be derivative of the outside function, derivative of a cosine, which is a negative sign of u, but you have to pay for it, multiply by u prime. This is your formula. Okay. Now we're going to operate. So what is going to be g prime of x? G prime of x is equal to 5 is a number, 5. Derivative of the cosine, negative sign. Negative sign of what? Negative sign of the angle, 2 pi x. Okay, so that would be the derivative of the outside. Now you have to multiply by u prime. U prime is the derivative of the inside, 2 pi x. What is derivative of the 2 pi x? Derivative of 2 pi x.
2 pi.
Excellent, 2 pi. Yes, pi is a number, okay, it's a constant. So derivative of 2 pi x is 2 pi. 2 pi. Okay, but again, we have monomials. Look at this. We have a 2 pi here. We have a -1 here. And we have the 5 here. So you have to multiply all of them together and to get the final answer. So g prime of x is going to be equal to, okay, is equal to what? We have a 2 times 5, 10, -10 pi. -10 pi. -10 pi, but this is going to be the sign of the 2 pi x. So this is, the way you are going to see it later on. We have a very famous function. I'm going to show you that function too. The way we are going to use this one, later on. Any question? So make sure don't miss that u prime. You have to multiply by derivative of the inside function. Any question? Of this category, you are going to see this function in future. Okay, number 5. What is this famous function? Is g of x. You see it's going to be g of x equal to the, let's say, 50. It's going to be 50 sine of, okay, 50 sine of the pi 12 times x. When we see it in future, this x is t. Okay, x is going to be t. And this is going to be a part of a famous function that we're going to call it a temperature function. Towards the end of the course, we are going to learn how we are going to find the average value of a function. You see, for example, when you talk about the temperature during the day, if you say what's the temperature today, you see the average temperature is between 76 and 95. So the question is going to be how they determine. This is going to be the temperature of, for example, San Marcos area or Oceanside. The way they are going to do it, we are going to have a special formula for it, but that formula related to this function. Each region would have a similar, over the years, we collect information, data, and we provide a mathematical modeling for the temperature of each region. So for example, if this is going to be for the California, if you consider something like for Alaska, this would be different. But this this quotient inside, see this coefficient would be different, and you may have some extra terms. But the foundation is going to be this function. So you will see this function and the way we are going to operate it. So that's why you want to meet it if you like, and get the derivative for the time being and use and enjoy it at the end of the course. This would be, you get one question on the final related to this function. Okay, so why not? Let's see what's the derivative of this function. Again, 50 is a number, coefficient, keep it. It's sine of pi 12x, so it's a composition of two functions. So we have to find the derivative of a sine function, which is cosine, and then u prime. Okay, so quickly, this is going to be g prime of x. So g prime of x is going to be what? We keep the 50 as is. So it's going to be the derivative of the sine. The derivative of the sine is cosine. Cosine of pi 12x. But you have to multiply the derivative of the inside, pi 12x. As we did it for the other one, pi 12 is a fixed number. So the derivative of pi 12x simply would be pi 12. Okay, so it's a composition of two functions. The outside function is sine, the inside function is pi 12x. Now you have to take care of these monomials. Okay, you have pi 12 here and the 50. So you can put them together or you can simplify first. See, you can simplify it by 2, for example. So that gives you 25 and that gives you 6. So the final answer is going to be g prime of x is going to be, you multiply these two together, it's going to be 25 pi 6 times that by cosine of, okay, cosine of pi 12x. So you will see this function and the way we're going to operate with this, okay, to get the results. Any question? So this is one version of the application of a chain rule and the trigonometric function. So, it's a composition of two functions and we just do it. There is going to be one more version of this type of problems. I'm going to give you one to motivate it. I don't usually write this one as a formula really, and we can do it. But I do this example, so get to know it, then I give you the formulas if you like. You see, these functions, trigonometric functions, they didn't have any power, if you like. So how about if this happened to be sine squared, or this happened to be cosine to the 7, etc. Okay, so this, in fact, when you compose the sine and this function, you compose two functions. How about if you have 3 functions? Okay, so this would be, we call it the derivative of the powers of trigonometric functions. So that's the ways. Okay, so how about the derivative of the powers of the trigonometric function? That would be our last case. Let's motivate it first and then we go for it. It's very interesting, these powers. In calculus 1, you are not going to use it much, but in calculus 2, we do quite a lot. So the chain rule and the derivative of, so what's going to be the chain rule and the powers of trigonometric function? So that would be the chain rule and the derivative, or just powers of trig functions. Trigonometric powers of trigonometric functions. Okay, let's start with one example. You guess it yourself, and then if you can guess all the time, so that would be fine. But otherwise, we give you the formula. Some people like to see it as a formula. So, and that is it. So suppose, we start with this example, then make it official. Look at this example. So we would like you to find the derivative of this function. Okay, find the derivative, okay, of the function, What is this function? This is it, f of x equal to sine to the fifth of the x squared. You see, this is the one that you want to do. It's a composition of functions in this case. How many functions can you see here? Sine to the fifth of the x squared.
3.
Yeah, excellent. It's going to be 3. So it's a 3 function. Why? Because you see, you have the power here. So that's a power function to the fifth. Then the trig function, sine. Then the u function. Okay, so it's a composition of 3 functions. Chain rule. When you want to do the chain rule, remember, we just do the derivative of the functions, the product of the functions that we compose to get to the original one. So when you want to differentiate it, you see this is the way you would think about it. Solution. You see, if you rewrite it in this form, you don't have to, but you see this is f of x, and this is going to be the sine of the x squared, everything to the fifth. You see, if you forget about this one, this is the one that we did already. Okay, outside, inside. But you have a power over here. So if you want to differentiate it, chain rule. You just find the derivative of the functions that you compose. So power first. You see power, action of differentiation for the power. You bring the power down. It's going to be 5. Okay, 5 sine. Okay, 1 dot. The derivative power is 5. It's going to be sine to the fourth of the x squared. That's a power function. Okay, then sine function. Derivative of a sine, cosine of what? X squared. Then derivative of x squared, which is going to be 2x. Okay, so when we get the derivative of the power of the function, and that's exactly what would happen. You do the power first, bring it down, 5, 4. Then the derivative of the trig function, it's a sine, cosine of the x squared. Then the u function. The u function, which is going to be your u prime. But you're not done, you have to take care of the monomials. We have a 2x here, and you have this coefficient 5 here. So it's going to be 5 times 2, 10x, and you move it up in front. So f prime of x would be, f prime of x is going to be equal to the 10x sine to the fourth of the x squared times the cosine of the x squared. So that gives you the derivative of your function. This is the most general problem that you can have when you're dealing with the derivative of the trigonometric functions. Any question? I'm going to write it down as formula for you in a minute. So this is sine, it can be cosine, tangent, secant. So basically, in general, this is how we did it for this group. So your f prime is going to be, you see, you do the derivative of the power function. This is your power function, whatever power it is. So you bring the power down. Then you times it by the derivative of the trig functions. Trig function, trigonometric function. Okay, and at the end, you do it u prime, derivative of the inside function. Okay, power function, trig functions, inside function. That gives you the formula that you're going to have. Okay, so officially, we can give you the formula. So Therefore, and this is what you have. If you like formula, you don't need the formula really. If you just follow this instruction that you have over here, then you'll be able, okay, to deal with all of them. But if you want the formula, I give you the formulas. That's it, the first case. If you want to do the power of the sine, so the derivative of sine to the n of u is equal to, you see the power first. Power, you bring the power down. N sine to the n minus 1u. That's a power function. Derivative of the trig function. Derivative of a sine, cosine. Cosine of u times derivative of the inside function, u prime. Of course, then you simplify it if you need it. That's it. That's formula for the sine. Any question? Repeat it for the cosine. So the second part is, how about derivative of a cosine to the n of u? Bring the power down. Power first. N cosine to the n minus 1 u. That is going to be power function times derivative of the trig function. Trig function is cosine. If you have a cosine, negative sine of u times the u function, derivative of the u function, u prime. Okay, so that would be power of a cosine. Next, number three. Number three, let's take the tangent. Tangent to the n of u prime is equal to, we bring the power down, power function, n tan to the n minus 1 times u. So that's a power function. Derivative of the trig function, derivative of a tangent, secant squared of u times derivative of the inside function, u prime. See, let's check this formula, everything would be nice. And the last one, derivative of a secant, power of a secant. So derivative of a secant to the n of u is power, we bring the power down, n secant to the n minus 1 of u times the derivative of a secant. Derivative of a secant would be secant tan, secant of u, tangent of u, okay, times the derivative of u, which is u prime. When you do it, then you simplify these two. This secant, you say this is secant to the first power, and this is secant to the n minus 1. So you multiply them together, that gives you secant to the n. So we just leave it this one. When you do it, then you have to take care of that simplification at the end as well to get this one through. Okay, if you like to memorize the formula or just add it to your formula sheet, that's fine. But as we talk about it, this is it. It's all composition of, you see, that's a tree function. In future, if you replace, for example, this u by exponential function e to the x squared, for example, in that case, you are going to be composing something like 4 or 5 functions. It doesn't matter. You can compose as many functions as you like. But when you differentiate it, you do one at the time. One at the time, but you multiply them together and simplify it, and that would give us the final answer. Okay, so you have to practice. We need 4. We give you one of each, one of each method for your next quiz, next test, and of course, one on the final. As I talked about it the other day, you are going to give something like 4 questions from the chain rule on the final. Okay, and we need only, we finished, we need only one more of these. We have to wait for the right through the end, but otherwise you get something like half of those so far. Okay, so let's get practice to see how we're going to simplify it at the end, and then be done with the chain rule. Okay, are you ready? So let's get example. Again, keep it in order. Nice formula. Okay, remember I checked it. I talked about it the other day too. It's a product of these functions. It's not a product rule that we use for it. There's the composition functions. Okay, so there you are. We need, for example, of these power functions. So I'd like to find the derivative of each function. So find the derivative. Okay, find the derivative of each function. The kind of most general type that we're going to have. You will see one of these on your next, they usually talk about one of them on your quiz and the test that we're going to have. Okay, the first one. The first one, this is it, y equal to 4 sine cubed of the 2x. You see that's going to be the one. So as you can see, this is a composition of, you have a power function, you have the trig function, and you have the u function. So you differentiate each one of them and just multiply them together, simplify it. Okay, solution. That's it. Y prime equal to 4 is a number. Coefficient, you keep it. You see, you need the derivative of a power function. You need derivative of the trig functions. And at the end, you have the u prime. This is the way you operate. Power, you bring it down. 3 sine squared of the 2x. You're not going to change anything else, okay? Just power. Coefficients done, okay, and the power 1 done. Now the derivative of the trig function. The trig function is sine. So the derivative of a sine, cosine. Cosine of what? Again, 2x. You don't change anything else. Okay, then the derivative of the u prime. U is 2x, so u prime would be 2. That's it. Okay, it's a trig function, so you should have 1, 2, 3. The first one, power function, 3, 2. The second one, trig function, sine, cosine. And the inside function, 2x, 2. But you have monomials. You see monomials here. 1, and you have a 3, and you have the 4. So you have to multiply them together. So your y prime is going to be equal to 2 times 3 would be 6. 6 times 4 would be 24. So we get 24 sine squared of the 2x times cosine of the 2x. And that gave you the final answer. Okay, y prime equal 24 sine squared. This is how we expect you to write the final answer. If you can write it down quickly, put them together, we accept it. Okay, no problem. But this is the way we are going to ask for it. Any question? So that's a sign. Change it to the various okay, trig functions. So this number 1. Number 2, this format is very popular. Okay, we have a y equal to, the secant type is the most popular one. So it's going to be 2 secant to the 6 of the radical x. This is a kind of popular one. Okay. Again, 2 is a coefficient, it's a number, no problem, we keep it. We have the power function to the 6, we bring it down. Then we have a secant, we have a secant 10. And we have the radical x, 1 over 2 radical x. Okay, so what's going to be the solution? This is going to be the solution. Okay, so we go with the y prime. 2 is a number, you keep it, times power first, bring the power down. 6 secant to the 5th of the radical x. Remember, you're just changing the power only. Everything else is going to be the same thing, especially, okay, especially the angle is the radical x as is, okay? So that would be the power function. Next, secant. If you have a secant time, again, secant of the radical x, tangent of radical x, you stay with the same u. Okay, so that's the derivative of a secant. Derivative of the radical x, we talk about it. Derivative of radical x, in case of these examples, we write it down right away. 1 over 2 radical x. Again, we accept it if you write down as x to the negative 1. Any question? Now, secant is tricky for simplifications. Okay, you have to, this is it, you have to simplify these monomials. You see, 2 here, 6 here, and this one. So you have to multiply. You can simplify these 2 and 2 first. Then the leftover is going to be 6 times 1, which is 6, divided by the radical x. Okay, this is the way we simplify it. So y prime is equal to the 6 over radical x, 6 over radical x. Now, in the case of the secant, your extra job here is, you see, this is secant to the 5th. There's always going to be a leftover of a secant here, because the derivative of a secant is secant 10. So take care of this one too. Secant to the 5th power, secant to the 1st power. 5 plus 1 would be 6. So that gives you secant to the 6th of the radical x and the tangent of the radical x. So that would be the final. It is a kind of most general problem or differentiation that you can have when you're dealing with these trigonometric functions. Okay, so be careful about the secant. It's a secant, what secant here? Because of the power function, the derivative of a secant is secant 10. So there is a secant to simplify it. And you multiply with the common base, so you add the powers, 5 plus 1, 6. This is the one, and the derivative of a radical x, we usually write it as 1 over 2 radical x, and you simplify. It's a very popular function for example, for calculus 2. They like this one. Okay, any question? So I should give you one with the tangent. Again, the tangent case is popular. Especially, with that radical x or otherwise. So let's have one tangent, and that's it. We get the y equal to the 7. Okay, 7 tangent to the 5th. Okay, tangent to the 5th, but of the x squared. Okay, of the x squared. Again, as you can see, it's a power function of a tangent. So 7 is just a coefficient, we keep it. The power function is to the 5th, trig function is a secant, and u function is x squared. So the result is going to be solution y prime is equal to the 7 is your coefficient. Start with the power function in your first parentheses, you bring the 5 down. 5 tangent to the 4th of the x squared. You're just changing the power. Okay. Times derivative of the trig function, derivative of the tan, secant squared. It's a secant square of the same function, x squared. Times it by derivative of the inside function, derivative of x squared, 2x. That's it. But we have to simplify. Monomials, 2 coefficients, 2, 5, 7. So that's it. 2 times 5 would be 10. 10 times 7, 70. So y prime would be 70x tangent to the fourth of the x squared, and this is secant squared of the x squared, the final answer. Okay, so this is the way we are going to write it down. Any question? So these are mostly the one that you're going to have with this trigonometric function. Just give you one more for application problems in future. Okay, you may be given something like y equal to. Again, this is very popular, it's used. So it's going to be y equal to the, let's say 10 cosine. Okay, 10 cosine of the 3/4 of t. It's going to be for time, electricity, wave, etc. So they may use a different variable. This is the variable t that can stand for the time. Okay. Let me just put the power here, something like, let's say, a squared. So the 10 cosine square of the 3/4 times t. You want to differentiate respect to the t, it doesn't matter. Again, it's a composition of three functions. Okay, so solution y prime. 10 is the number, the coefficient, you keep it. That's 10. Now first the power function, you bring the 2 down. It's going to be 2 cosine. Okay, cosine of what? Cosine of the 3/4 of t. That's a power function. Times that by, you have to keep these parentheses, remember, especially this one. Derivative of the cosine. Derivative of cosine would be negative sign. Negative sign. Sine of what? Same angle. 3/4 t. Okay, so that's the derivative of the trig function times derivative of the inside function. The inside function is 3/4 t, so inside would be 3/4. Okay, any question? So be careful when you do this type of terms in applications. So again, the 10 is the coefficient, the power function, we bring the 2 down, everything is the same. We're dealing with the derivative of a cosine, which is a negative sign, same angle, and derivative of the inside function, which is 3/4. Now you have to simplify monomials. Okay, this is it, we have quite a lot. We have a 3/4, 2, 10. So if you like, you can simplify these 2 and the 4 here. That give you 2. And you have a 10 here. So we can simplify the 10 and the 2. Or you can multiply together, then simplify at the end. So that would be 1. So what's going to be the leftover for the final answer? So y prime equal to the number, we have the 5 here. Okay, 5 times 3 would be 15 pi, and there is a negative here. So it's going to be negative 15 pi. Okay, I simplified everything else. Negative 15 pi. Then we have a cosine of 3/4 t times that by sine of the 3/4 t. That gives you the final answer. Okay, so keep it in order. Don't make it complicated. It's going to be a straightforward problem, really. Nice problem, of course. So the only thing is missing that this is, we just focus on trigonometric function, so nothing is missing. But to finish this concept, when we get to the end of the course, we introduce the inverse trigonometric function, and instead of giving you these type of functions for the questions on the final, we give you inverse trigonometric function. It's the same procedure, but and the reason that we do it at the end is that they are going to be used in calculus too. right at the beginning of calculus 2. So if you talk about it now, when we get to the end part, last part of the course, then you'll be confused. But you can, you can learn it anytime you like, in any order. And that's it. This is the 2.4. So I give you a break. Okay. Then we get to 2.5. It's another application of the chain rule, but and the procedure is very important for the application that we're going to have. Okay. So let's have a break. Then I come back and talk about that. It's a kind of a different format for the derivative. We call it the implicit differentiation. And then when we do the 2.5, we are almost done with all formulas of the differentiations. Then we can sit back and enjoy the applications of these derivatives. Okay, so this is the way we do it. We hope to be able to do a couple of more sections before the end of the week. Then you be prepared for the quiz. Okay, so let's have something 10 up to the 10, 12, even 15 minutes, because the next comp is important. Give you a break. Then we come back and we do the 2.5. Okay, see you then. Okay. So what we're going to do, we're going to look into the derivative of the function when the function is given to you in different formats. You see this differentiation that we did so far? All these functions, the equation of the function is given directly, and it's already been solved for y. You see, y equal to. When the equation of a function is given to you in this form, and we say the function is defined explicitly, means the y is there, it's already given to you. But when you're dealing with the application problems in science, there are going to be a situation that the relationship between x and the y would be given to you, but it may not be given to you as directly solved for y. So your function would be given by an equation in terms of x and y. And most of the time, it's not possible to solve for y. But what we can do, we can apply the chain rule in order to find the derivative of those type of functions. This type of differentiations, differentiation is going to be referred to as an implicit differentiation. Okay, so we're going to discuss that one. That would have many applications because you are not going to have the directly okay, and a statement, a formula for your function, but you'll be able to find the derivative. And the derivative is the one that you are interested in science, because the derivative is what? Is rate of change. In the case of the moving object is going to be, okay, velocity. And then later on, if you have the derivative, you can answer any question you have. You can have a maximum, find the maximum minimum value. So that's why these type of differentiations are very important. Okay, so that would be the topics of the section 2.5. Very easy procedure, but quite important. Okay, so we're going to talk about that one. It's 2.5. 2.5, implicit differentiation. You need these type of ideas to get a more derivative of the more complicated functions in future. Okay, so what is implicit? Okay, implicit differentiation. We do this one in calculus 3 with a kind of a short form. That short form depends on the function of two variables, and you don't have the function of two variables in calculus 1. So you're not going to use those type of formula in case you see it somewhere online for your test. We don't accept it, the solution at this level. Okay, there you are. So what is going to be implicit differentiation? So I give you a different definition of a format of a function. So this is what we know so far. If a function, okay, if a function f is defined, if the function is going to be defined by the equation, okay, equation of this type, you see y equal to f of x. So you express the y in terms of the x. If this is going to be the case, we say this function is defined explicitly. So then f is said to be and explicitly, and that's expression. Explicitly means directly defined, explicitly defined. Okay, defined function. So that would be the case 1. So this is explicitly defined function. Okay, explicitly you have the y. So in this case, if you want to differentiate, nothing to worry about. Derivative of y would be y prime, and then derivative of f prime, we're just using the formula that we had so far. Okay, so in this case, In this case, the derivative of the function, the derivative of the function is what? Is y prime equal to the f prime of x. That can be found by using the formulas that we talk about it so far. Okay, so for example, you see, for example, if the function is going to be given explicitly as if you have y equal to x cubed plus 5 sine x, you see, easily we differentiate it. Then what's going to be derivative? Then we simply differentiate. So y prime would be, when we get to the first one, it's just power rule. X cubed would be 3x squared plus 5 times the derivative of a sine, which is a 5 cosine of x. Okay, so we're done. That's what we've been doing so far. Any question? So that's explicitly defined. Now, if you have a function that's defined by an equation mixed in x and the y together. Okay, so what are we going to do with that one? So taking the new parts. If the function, again, if the function, okay, if the function, again, y equal to the f of x, the function is going to function of x is given, okay, is given indirectly, is given by an equation in terms of equation mixed together or in terms of x and y, such that, in the form that, such that, for example, you have a combination of the x and the y, it's going to be f of x comma y equal to the 0. Okay, so your function is here, but you don't have it directly y equal to. So you have something like x squared plus y cubed minus 3x plus sine x equal to the 0. So there is a y, but we don't have it directly, if you like, okay? You have to solve this equation for y to get the y in this form. But solving that equation is not easy. So this is going to be a situation you're going to have. If this is going to be the case, we say, oh, there is a function. It's defined implicitly by this equation, okay? So then the situation is the function f, the function f is said to be, okay, is said to be implicitly defined. Okay, implicitly defined. Okay, so that would be implicitly defined. Okay, implicitly defined function, if you like, okay? Defined function. Okay, so explicit is directly y is given to you, but implicitly is not given to you as an equation, okay, in terms of the x, but it's mixed together. So for example, okay, if we have this equation, if we have something like x cubed, okay, plus y squared plus y cubed equal to the sine x plus 5. You see if this is going to be the case. In this equation, it's an equation in terms of the x and the y that you're going to have. So imagine that y is a function of x. but you don't have the, the direct equation for it. So if you like, you can solve this equation for y, then you change it to the direct form, explicit form, but this is not easy to solve. Because if you want to solve in terms of the y is a cubic equation, good luck, how are you going to solve this equation? You can't do it. Okay, or would be almost impossible or difficult to do. So in this case, so this is going to be 1. You say, oh, there is a y, but I cannot find it. So, but I know that this is a function. Then this y eventually is going to be a function when you solve it. Is an implicitly defined function. Okay, defined function. Okay, that's going to be the case that we are going to be dealing with. Okay, but sometimes, like in algebra, the equation is easy. So, for example, in algebra, you see, note that if something given to you, like the way you do it in algebra, note that if you have something like how about 2x plus 3y equal to the 6, then then you can solve. One can solve for y. This is the way you do in algebra. So it's easy to solve. This is going to be 3y equal to the negative 2x plus 6, and then you divide. So that gives me negative 2/3 x and then 2. You see, you can solve it to get the y. But this is, you should be able to do the same operation, but the result is difficult. Because if you move the x cubed to the other side, you have a cubic equation. You won't be able to know to solve it. So what we would like to do is, we would like to see, although this y, y is a function, if you solve it, you get something like this. And so although this equation cannot be solved for y, but if you know that this y is going to be differentiable, we can differentiate it. We can differentiate both sides and find the y. How are we going to do it? We use the chain rule. So when you differentiate both sides, when we get to the x cubed, derivative would be 3x squared. But when we get to the y cubed, remember y is a function. So there is something in terms of the y. So when you're dealing with the y cube, it's like u cubed. So you have to apply the chain rule. And remember the power rule? You bring the 3 down, 3y squared, but times the u prime. U prime is y prime. So you differentiate. When we get to the x, you just differentiate using the power rule. When we get to the y, we use the chain rule. Y cubed, 3y squared, y prime. Because the y is going to be kind of a function that you don't have it. Okay, so this is going to be the question that we're going to answer in this section to make it official. Okay, any question? So make sure you know the difference between these two quantities that we have. In this part, it's already solved for y. In this term, it's not solved for y because it's not easy to solve or sometimes impossible to solve. But we keep in mind that this is going to be y is a function of x. Okay, and when we change, when we get to the differentiator powers of the y, we're just using the chain rule, and then we solve for y prime. So let's propose the question and answer that question. So the question is going to be this one that we're going to answer. How are we going to find the derivative of the function when it's given to you implicitly? Okay, so the question is going to be if a function, okay, if a function y equal to the f of x is defined or given to you, is defined implicitly, means it's inside an equation. if a function y equal to the f of x is defined implicitly by the equation by the equation f of x comma y equal to the 0, means a combination of x and y. The question is going to be find y prime. Find y prime, or this is the notation that used in your book, dy dx, differential notation. I'm not going to use this notation for a while because I'm going to use it when I give you this type of definitions, okay? Call it differential form, but we can use it if you like. Okay, so that would be our question that we're going to answer. So to answer it, as I talk about it, you are going to differentiate. So what's going to be the solution? So the solution is you differentiate. When we get to the x, just use the power rule. Derivative of x to the n is n x to the n minus 1. But when we get to the power of y, it's the chain rule. Derivative of y to the n would be n y to the n minus 1 times y prime. So let's give you the answer. And then examples, how we're going to do it. This is it. Just make sure you understand the idea. Otherwise, it's just a nice application of a chain rule. So what's the solution of that question that I propose? Solution is going to be, if you want to find the y prime from that equation, this is the instruction. You differentiate both sides of the equation. Differentiate. Okay, that's it. We are going to differentiate both sides of the given equation, both sides of the given equation using the following formula. When we get to the power of x, we just use the power rule. Derivative of x to the n is n x to the n minus 1. But when we get to the power of y, when we get to the power of y to the n, use the chain rule. So what's the chain rule? You bring the power down, n y to the n minus 1, but times y prime. Because there is something inside the y. You see, there is nothing inside the x because the x is independent variable. But y depends on x. Y is a function of x. Y is like u. So you have to apply the chain rule. The chain rule, derivative of the outside, n y to the n minus 1 times the derivative of the inside, y prime or u prime. Okay, so differentiate both sides of the equation using this formula and then solve for y prime. And then solve to find the y prime. For y prime, it depends if you use this differential notation, which is in your book or some of the books. So, or this one. I just use the first notation. That's it. You need a little bit of algebra when you want to solve for y prime. This method is going to be called implicit differentiation. Okay, so this method is called method of implicit differentiation. It's called implicit. It's called implicit differentiation. Implicit differentiation method. Very, very interesting method and very useful. And we are going to have a various application of this one. Okay, so when the question would be given to you, directly they ask you to apply the implicit differentiation. So you cannot use any other formula. Remember, you cannot use the idea of those, as I talk about it, function of two variables, which are going to be discussed in calculus 3. That's it. So we need to give you examples. There are kind of 3 different types when you're dealing with this type of problems. Okay, and we give you all the 3, and then you are done. Example. one question of implicit differentiation for the coming quiz and the test number 2. That's it. How we're going to do it? Apply. Okay, apply implicit. Apply implicit differentiation. Differentiation to find y prime. I just emphasize dy dx, which is used by some people. Okay, apply implicit differentiation to find the y prime or dy dx for each of the following. For each of the following. Okay, this is going to be this equation I'm going to give in. So there are two types. The type 1 is very straightforward. You're going to have only a power of y. So this is like x cubed. You're going to have one term in terms of the y to the fourth equal to 2x minus sine x. This is not going to be complicated, just power of y. Okay, are you ready? Differentiate both sides. When you get to the x is ordinary x. When we get to the y to the fourth is like u to the fourth. Remember the derivative of u to the fourth was 4. U cube u times u prime. It's going to be the same thing for this one. So you have to be worried about this. So when we get to this one, just remind you that the derivative that we're going to use is the derivative of y to the fourth. Chain rule. Bring the power down, 4 y cube times the derivative of the y prime. You see, previously used u prime, that's the derivative of the inside, which is y. So what's going to be the solution? Differentiate both sides. I just remind you, differentiate both sides of the equation. We differentiate x cubed, 3x squared, done. Plus, you differentiate y to the fourth. For the y, you use the chain rule, which means power down, power function times the derivative of the u function. U is y, so it's going to be y prime. Okay, derivative of x cubed, 3x squared. Derivative of y to the fourth, chain rule. 4y cubed times the derivative of the y prime. Remember, because there is inside y, there is something inside y, your function. But there is nothing inside x, so it's a 3x squared. Go on the other side, derivative of a 2x2, derivative of a sine, cosine. That's it. But you have to solve for y prime. To solve for y prime, you know that you have to isolate it. You keep it on one side of the equation. You move everything else to the other side. Then you divide by the coefficient of the y prime. So isolate it. Keep the 4y cubed, the y prime on one side. Move the other one to the other side. It's going to be 2 minus cosine x minus 3x squared. Okay, now to solve for y prime, divide by the coefficient of the y prime. Coefficient of y prime is 4y cubed. I just want to do it, so explain it for you, but otherwise we do it right away. So there's going to be 4y cubed, the y prime. You divide it by y cubed. You can do it right away. Okay, same thing here. It's going to be 2 minus cosine of x minus 3x squared. Everything divided by y cubed. Okay, I'm sorry, 4y cubed. That's a 4y cubed. It's going to be 4y cubed. Simplify, 4y cubed and 4y cubed would be out. So we get a y prime. Okay, so the final answer is going to be y prime is equal to the 2 minus cosine of x minus 3x squared divided by y cubed. So that gives you the final answer. Okay, any question? Of course, there are some restrictions. You don't have to write it down. We assume that this is going to be a natural domain. You see, since when you divide it by y cubed, you assume that the y is not equal to the 0. Because if you put the 0, you won't get anything here. So we assume that we are in a natural domain. So this means if there's going to be restriction, you consider it. So we are not going to be bothering about those type of restriction for our solutions. Okay, any question? So it's straightforward, but you have to be careful about don't miss the y prime.
How did you get rid of the 4 in the final answer?
Oh, I missed it. Thank you. That's 4. Thank you. 4. Excellent. Okay, so that gave me 4y cubed. Okay, so make sure that when we get to the y, just apply the chain rule. But otherwise, everything else is going to be kind of the algebra. And you cannot simplify this final answer, so we write it down as is. And that's case 1. Any question? So the case 1 is a straightforward. You have only one term, y to the 4th. Okay, that's easy even sometimes to solve for y first. But since they ask for the implicit differentiation, you are not going to rewrite the equation. You just do it as is. That's case 1. Any question? Case 2 is the one that you got to be careful. What's case 2? The case 2 is going to be, you are going to have a term containing the product of the functions. Then you have to apply the product rule. Okay, that's a little bit more involved that we are going to have. Okay, so this is it. Let's go and get the take the case 2. So we usually give you one question, so 2 parts to differentiate. One of them, of course, would be of the product type. So that's a product type. It's a 3x squared. Okay, 3x squared plus, and that would be x cubed, y squared, and this is going to be y cubed plus 5x cubed. The more interesting one. So look at this. You have the x cubed y squared here. And the y cube, we can take this one. So the thing that you have to consider is, we differentiate both sides. Divided up this first one is easy, that's going to be 6x. But when we get to this, you have to remind yourself that this is the product of two functions when you want to differentiate it. So this is going to be your first function. Okay, and this is going to be your second function. So you apply the usual product rule. You see the product rule, derivative of the first times second plus second first. So you got to be careful not to miss it. So when we differentiate it, this would be 6x. When we get to this part, derivative of the first times second first. Derivative of the first one, derivative of x cubed would be 3x squared. So it's going to be 3x squared times y squared. But plus the derivative of second times first. Derivative of a second one, y squared. What's the derivative of y squared? Derivative of y squared?
2y prime.
Excellent. 2y prime. When we get to the y, remember, we have to apply chain rule. We end up with the y prime. Power rule and the y prime. So derivative of the first 3x squared times second y squared plus derivative of a second 2y prime times x cubed. And then we continue changing the algebra, okay? So be careful about this product. So the solution is going to be differentiate both sides. Derivative of 3x squared 6x plus product rule. You have the first times second, derivative of x cubed 3x squared, 3x squared y squared plus derivative of second times first. We talk about the y squared. The power rule would be 2y, but since it's a y times y prime, that's the derivative of second times it by the first one, times it by x cubed. Okay, so that's the derivative of the first times second, second first. We go to the other side. They have y cubed, chain rule, 3y squared, but y prime. Always remember inside the y, there is a function. And this is going to be plus, the derivative of 5x cubed would be simply 15x squared. So this is how you differentiate. Remember, you have to differentiate both sides. Any question? So be careful about that product, and anytime you get to the y, remember you have to apply the chain rule. Now we have to solve for y prime. You have to isolate the y primes. So in this case, you have one term here, and you are going to have one term here. So you have to isolate them in one side of the equation, everything else on the other side. You can do to the right, to the left, but I do to the left all the time. So I'm going to keep this one. So I have two, okay, I have a 2y prime x cube here. This is the one, and then minus 3y squared y prime. Okay, and this is going to be equal to, on the other side, we already got the 15x squared. Now subtract this, minus 6x minus 3x squared y squared. Okay, we're just doing the algebra. Then we cannot combine this together, but you have to make it as one term. So we factor out the y prime. Okay, when it's more than one term, you factor out because you need the coefficient of y prime to divide both sides by that coefficient. Okay, take the y prime out. So we factor out the y prime. You see y prime left over. It's a 2yx cube, or in alphabetic order if you like, 2x cube y. That's a leftover of the first coefficient, and the second coefficient give you 3y squared, second term. On the other side unchanged, 15x squared minus 6x minus 3x squared y squared. Okay, there's going to be more algebra involved because we have more than one term. Now we divide by the coefficient of the y prime. So the final answer is y prime equal to, there you are. So it's a 15x squared minus 6x minus 3x squared y squared. Okay, and divided by 2x cubed y minus 3y squared. Okay, so that gives you the final answer. There's no simplification, sometimes you may have to be, you may be able to simplify, but be accepted because we are interested in the derivative at the moment. Nothing else. Okay, I mean, no, this cannot be simplified, of course. So this would be the final answer. Any question? So it's very nice procedure. You see, you don't have the function, but you can have the derivative of the function. That's the rate of change. You see, when you're doing something in science, you have the rate of change, you can substitute extend the y to get the rate of change at any level that you like. And that give you a prediction for a phenomena, whatever you're doing. Okay. Then later on, we can graph the function. We can find the maximum value, minimum value. We can do everything because we have the y prime. Okay, so that's a great theorem. Okay, to be able to do this type of ideas. Any question? No, there is only one tricky one, and that's the next one. That you got to be careful. Some people they miss this one on the test. Let's see what is going to be this. This is it. It's going to be a kind of a trigonometric function involved, but of this phenomenon. So let's see. You see, you are going to have something very similar, x cubed. Okay, that's x cubed plus 5x. Okay, 5x sine of y. So the y is going to be inside of the sine, cosine, tangent, or secant. And on the other side, we have the y squared plus 2 secant of x. You see this one? The difference is this. You see, it maybe comes with a sine y, tangent y, secant y, cosine y. So you got to be careful when you differentiate. Remember, we talk about it. When we differentiate, x cubed, easy, 3x squared. But when we get to this part, again, it's a product of two functions. Just remind yourself that this is going to be the product of two functions. So this is going to be your first function, and this is going to be your second function. Okay, now, the tricky part is this. Derivative of the first times second, derivative of the first one would be 5. Times the second one would be the sine of y. But important part is the other way around. Derivative of the second one times the first one. The second one is sine y. What's the derivative of sine y? Who wants to try it? Remember, anytime you get the terms containing the y, you have to apply the chain rule. So what would be the derivative of sine y?
Cosine y, dy dx.
Excellent. Yes, cosine of y times y prime or dy dx. Yeah, that's one. Very good. Excellent. This one, some people, they miss it. You see, when we get derivative of sine x is cosine x, done. But derivative of sine y, remember, it's like u. It's sine u. Because y is a function of x. There is always something inside the y that you got to be take care of that. So the derivative of sine y is the composition of two functions. The derivative of sine would be cosine y times y prime times dy dx. Okay, so as we talk about it, anytime you differentiate respect to the y, there is a inside function that would be differentiated, and that would be y prime. Otherwise, that would be fine. Okay, and that would have a very nice application for the derivative of the inverse trigonometric function in future. Natural log, a very famous function. If you want to differentiate it, you have to use these ideas. So that would be very, very important. Okay, so make sure don't miss it. That's the only case that you should be careful. So let's do it. Derivative of the first part, so that's the solution. We go with the derivative of x cubed, which is a 3x squared. Okay, that's going to be the one. Then this is a product of two functions. Derivative of the first times second, derivative of 5x would be 5. So that gives you 5 times the second function, sine of y. Okay, that's the one. Now plus the derivative of second function times the first one, plus the second function, derivative of a sine is cosine of y, but you have to multiply by y prime. Okay, that's the derivative of a second times the first function, times it by 5x. Okay, so derivative of x cubed 3x squared, derivative of the first times second, a second times first. Okay, going to the other side. We're going to the other side, the y squared, remember chain rule? It's going to be 2y times y prime. Okay, that's going to be the case. And the plus 2 secant x, you don't need the chain rule. So derivative of it's going to be 2 times derivative of a secant, which is going to be secant x tangent, okay, tangent x. Okay, so we differentiate both sides. Now we have to isolate the y prime to get these true. So the term of the y primes that we have are going to be this one. And then there is another one here. So isolate them, move them to the, okay, to the left. I'm going to move these monomials up in front. So I write it down as, I can write it down as a 5x y prime cosine of y. Okay, I just put the monomial up in front. Okay, I have this one, which is a minus 2y y prime. Okay, 5xy prime cosine y minus 2y y prime, which is going to be equal to, the leftover is 2 secant of x, 2 secant of x tangent of x. Okay, and you subtract minus 3x squared minus 5 sine of y. Okay, any question? So we isolate the y primes. We have two terms containing the y prime. So we have to factor out the y prime. So pull out the y prime. So the leftover give you 5x cosine of y. Okay, minus 2y. And nothing to be simplified. You just repeat this. 2 secant of x, tan of x, and that's a minus 3x squared minus 5 sine of y. Okay, now we have to divide by the coefficient of the y prime. This is the coefficient of the y prime. Okay, so this is it. So your y prime is going to be the following. So we get 2 secant of x, 2 secant x tangent x, and that would be minus 3x squared and the minus 5 sine of y. And you have to divide it by the leftover, which is going to be 5x cosine of y minus 2y. That is the final answer. This is a kind of most general problem that you can have this when you're dealing with the implicit differentiation. Okay, we just need it for future application, especially of this form of those inverse function, or we're going to see it in future. So anytime there is a y here, you have to apply the chain rule. And the y can be comes with, the power function, it now, by now. When you're dealing with the chain rule, there are two types. You may get a power function, or you may get a composition function. So it's a sine of y is going to be kind of composition one. So you have a similar one in that practice quiz. For the practice quiz number 2, it's already there, but I'm going to update it this afternoon and bring it down to the Vic 3 assignment so that you can see it. I think in that you have the secant of y maybe on that practice one. So this is the one that you have to pay attention for, this type of argument. Okay, any question? Now, quickly, what is going to be the application of this type of problems so far? Okay, of course. What else? Tangent line problems. Okay, so we are very much interested in finding the equation of a tangent line. You know that this is rate of change. It can be the slope when we get to the tangent line. So if they give you a point and ask for the tangent line to the graph of the function that are here and the formula is missing, then what we can do is you have the y prime. We usually plug in, remember the value for x to get the slope. In this case, we have to substitute for x and the y to get it. Okay, so that would be our second problem of this section. Then we are done. Okay, so what is the tangent line problem in the case of the implicit differentiation? In your next quiz, you are going to get one tangent line problem, and that would be two parts. The first part, the equation would be given to you directly. You have to use the chain rule to get the equation of tangent line. The second problem, the equation would be implicit, and we're going to do it. Okay, and we repeat it on the test. So again, you see it on the practice one that we're going to practice. We give you the solution of that practice quiz by the end of the week. Okay, so let's check to see how we're going to do it. So that would be your second problem in this section. The first one, just find the derivative. One question, two parts. The second one, about tangent line problem. Okay, so there you are. Example. The example is going to be, we want to find the So this is going to be, just remind you, it's a tangent. It's a tangent line problem. But of course, for the implicitly defined function. There you are. The first one, we want to find the equation. Okay, find the equation. Find the equation of the tangent line. Equation of the tangent line to the graph of this function, to the graph of the function or of the equation. And this is it. The equation is x y squared minus y minus 2 equal to the 0. And of course, we want to do it at the point. Okay, point is 1 and 2. They usually give you the point rather than the x values. Because otherwise you have to find it yourself, and sometimes it would be difficult to solve for y. So that would be, okay, that would be given. Okay, so it's a tangent line problem. You know what to do. You need a point. The point is already given to you. Okay, so you have nothing to worry about the point. So I need a point. So the point is given. You call it P, which is 1 and 2. So this is going to be your point. But you need the slope. This is calculus. The slope is always derivative. So M is going to be y prime, but it's going to be y prime when you evaluate it at these points. This is the notation they're going to use. And sometimes you have it in some problems in your book. Just want to make sure you understand it. Okay, they say the slope is y prime at 1 and 2. So this means you differentiate both sides of this equation implicitly. Then you substitute for x and the y, x equal to y, y equal to the 2, and you solve for y prime. Okay, so differentiate both sides, substitute for x equal to 1, y equal to 2 to get the y prime. That y prime would be m. Okay, you don't have to solve it for y prime, but you have to substitute first to get it. Okay, so this is the way we do it. So let's bring the equation and take care of the differentiation. So x y squared minus y minus 2 equal to the 0. Again, you got to be careful. The first one is a product of two functions. Okay, x, just make sure you don't forget it. Some people, they make a mistake here. So you have to take it as a product of two functions. So this would be your first function. And this is going to be your second function. So remind yourself that you have to apply the product rule. Derivative of the first times second, derivative of x is 1, but I write it down so you know what is going on. So that is going to be the derivative of the first times second. Derivative of the second times first, y, you have to apply the chain rule. Is going to be 2y y prime, okay, plus 2y y prime times the first one, x. So that's the derivative of x y squared, okay? X y squared, derivative of the first one times second first, y squared, 2y y prime times the first one, minus derivative of y. What's the derivative of y? Derivative of y,
2y prime.
y prime. No, it's going to be just y prime. Remember, the power is 1. 1 down would be y to the 0, which is 1. So just derivative of y prime. That's it. Okay, derivative of y is y prime, because there is, the power is 1. So that's 1, derivative of 2 is 0. So that give you 0 here. Any question? So the root of y squared is 2y prime because the power is 2. The root of y, you know, 1 dot. 1 done, y disappear. So that give you just y prime. Okay, so this is it. So we have the y squared plus 2y y prime x minus y prime equal to 0. You see, since the slope problem, so you substitute first, then you solve for y prime. You don't have to solve for y prime first. Some people, they do it. It's easier for you because you want to find the y prime at 1 and 2. So remind yourself that you have a point. It's 1 and 2. So this means you go to this equation, you replace the x by 1, you replace the y by 2, then you solve for y prime. You see, that make it easier for you to do it. So substitute, it's going to be 2 squared, okay, plus 2y is going to be 2 times 2, y prime is missing, times x, which is 1, minus y prime equal to the 0. Okay, so we substitute first, then we get the y prime. Now simplify 2 squared is 4. 2 times 2 would be 4. 4 times 1 is 1. So we get 4y prime. And that would be minus y prime. Simplify, combine the like terms. That give you 4y prime minus 1y prime. That give you 3y prime equal to the 0. Okay, so 3y prime is equal to the negative 4. And the y prime, okay, y prime would be negative 4/3. That is going to be the slope. M is negative 4/3. Okay. So when you do the slope problem, you don't have to solve for y prime first. Just differentiate it, substitute the given numbers because the point would be given to you. Okay, the point would be given to you. So get the point first and then the m. Now we are ready to give you the equation. So the point is 1, 2. Okay, the point is 1, 2, and the slope is negative 4/3. Y minus y1, y minus 2. M, the slope, negative 4/3 times x minus x1, x minus 1. You have to simplify it. So it's a negative 4/3 x plus 4/3. So add the 2. So y is equal to the negative 4/3 x. Okay, plus 4/3 plus 2. 2 times 3 would be 6 and 4 would be 10. So y equal to the negative 4/3 x. Okay. Is a negative 4/3 x. 2 times 3 is 6, 6 and 4, 10, plus 10/3. So this would be the final answer. Equation of a tangent line. Any question? So when it's on the test that 2 different types of the tangent line takes a little bit time, but manage your time, you practice, you need to be ready for it to get this true. Again, you just differentiate and just substitute first, then solve for y prime. If it's going to be just the derivative of the function, you have to give us the y prime, but not for this one. Okay, that's a kind of a type 1. Any question? Should give you another one. Again, be careful not to miss these products that you have, okay, on that. Otherwise, it's a straightforward problem. Okay, so we give you another one. And you have something like 4 in your practice one. And if you want to pick the problems from that section, from your book, you better at least take one of these of the tangent line problem in the implicit case. So you practice. Okay, there you are, another one. There is something about this one that the people, they miss it. I want to explain it. So find the equation again. Find the equation of a tangent line. Okay, equation of the tangent line. Equation of a tangent line to the graph of this equation. To the graph of this equation. Your equation is y to the fourth plus x times y equal to the x cubed minus x plus 2. Again, implicitly defined. Oh, I'm sorry, I didn't give you the point. At the point, okay, at the point is 1, 1. That is going to be the case. So as I talk about it in this type of problems, the coordinate of the points would be given to you directly. Okay, so and this is it, a solution. So we have a point is just 1, 1. So that's going to be your point. So we need the slope. It's implicitly defined function, so the slope would be y prime, but it's going to be y prime when you evaluate it at 1, 1. So this means you find the derivative of the equation. You replace the x by 1 and y by 1 first, and then you find the slope, okay? So bring the equation and differentiate it. So this is the equation that I have. Is x cubed minus x plus 2. You see the people, when they handle this one, we differentiate it. If y to the fourth is straightforward because it's going to be 4y cubed times y prime. But when we get to this one, you must remember that you have to use the product rule again. You see the product rule for the first term, which is going to be the x would be the first term, and the y would be the second one. Okay, derivative of the first, derivative of x is 1. Times the second one would be just 1 times y. But derivative of a second times first. As we talk about the derivative of y is y prime. So it's going to be y prime times x. Okay, so the situation that we have with this one on the test, some people miss that they have to apply the product rule. You see, it's x, y, it's a product. Okay, it's a product of two functions, so you have to apply the product rule. And keep in mind that the derivative of y is y prime or dy dx, whichever you feel more comfortable. Okay, so we can differentiate it. So that gives you 4y cubed the y prime. Then we have to apply the product rule. Again, I write it down so you know what's going on. So it's going to be plus derivative of the first times second. Okay, this is it. Derivative of x would be 1 times the second one, y plus derivative of the second times first, derivative of the y is y prime times the first one, which is going to be x, y prime. Okay, that's a derivative of that. The other part is easy. Remember, you differentiate both sides. So that's ordinary differentiation that give it 3x squared minus 1. Okay, so this is what we have. We have a 4y cubed y prime. We have the plus y, and this is x y prime is equal to the 3x squared minus 1. It's a tangent line problem, so don't solve for y prime now. You want it at 1, 1. Okay, so you remind yourself that I have a point. So this means x is equal to 1, y is equal to 1, so I have to find the y prime. Okay, so substitute these numbers first. 4y cubed y is 1, so you don't have to write it, but this is what would happen. Okay, plus y is 1, plus 1, plus x y prime. X is 1 times y prime equal to 3x squared minus 1. Again, x is 1. So I just write it down, you know what's going on. Okay, so just make sure you substitute first, then go for it. So this is it. 1, you know, that gives you just 1. You get a 4y cube here. We have a positive 1 plus 1, and that would be y prime. And on the other side, we get 3 minus 1. Combine the like terms. You have the 4y prime and 1y prime is going to be 5y prime plus 1, and that gives you 2. So 5y prime is going to be 2 minus 1. Okay, this is it. So 5y prime would be 1. So the y prime would be a fifth. So this is going to be the slope. So the slope is going to be 1/5. Any question? Again, pay attention, you know, not miss any signs, anything. So we have the slope and a point, so we can find the equation of the tangent. So P of 1, 1, the slope of 1/5. Equation of tangent line, y minus y1, y minus 1, m a fifth, x minus x1, x minus 1. So you have to simplify it. You have to solve this one for y. So we distribute it, it's going to be 1/5 of x minus 1/5. Add 1 to both sides and simplify. So that gives me y equal to 1/5 of x, okay, minus 1/5 and plus 1. So common denominator, that gives you 1/5 of x. It's a negative 1/5 plus 1. It's going to be down. It's like a negative 1/5. And that's a 5/5. So the final answer would be y equal to 1/5 of x minus 4/5. So that would be the final, and that would be your final answer. Okay, so that's the problem of the tangent line in a case of the implicitly defined equation. And we are done with this section, which is implicit differentiation 2.6. Any question? So so we are done almost with all different formulas for the derivative of the function. Again, 2 functions are missing, natural log exponential function. I just stay with your book, this new edition. You know, they talk about the natural log and exponential function at the end. So we come back to it. It would be better for us. It's easier. So what we are going to do next, we do it tomorrow. We are done with the formulas. So the question is how we're going to use it. There is a very nice application. There are kind of 2 different types of application of these ideas that we talk about it for application in science. And there is one that we call it related rate equation, if you like. We are going to discuss that one, and that would enable us to finish this chapter. And this would be a nice place to give your give your next quiz. So we finish that section tomorrow, okay, and then we practice for practice quiz number 2. I start going over that practice quiz that we're going to have. Okay, that related rate equations are going to be quite interesting in everyday life. For example, you see when they talk about the unemployment, they say unemployment rate is going to be 4%, 5%. So they talk about those type of rates and a specific time, if you like. So far, the derivative of the function y is a function of x. So you find the rate of the y respect to the x, if you like. But in everyday life, this x and the y can be function of the third variable, which is the variable time. You see, at different time, you are going to be at different position. You see, at this time, you are going to be at the position 1, 1 in three-dimensional 1, 1, 2. 2 seconds later, you are going to be at different notation, different parts. So that x and the y can change with respect to the third variable, which is time. So we're going to have the rate of the y and the x respect to the time, or rate of the function respect to the x. That's quite interesting concept. So we are going to discuss that one tomorrow. There are different applications in different part of science. So it depends what we're going to do in future. So what we are going to do, we are going to give you something like 4, 5 different cases, 5 different problems. And we usually test 2 of those problems on this coming quiz and the test. But in future, you're measuring physics, you're just using your own examples. If you're measuring business, biology, etc. So that is going to be the idea for tomorrow. Okay. So there are some problems that I may post them, so that I'm not going to. I'll write it. It doesn't matter. So I bring down the quiz down as the activity for for this week, and I go over there to practice quiz starting maybe tomorrow. And that's it. Any question? So read your crucial part is really the one that we did 2.4 and 2.5, especially the chain rule. Focus on that one. So if you haven't done your test, you know that this is the second day that you can take your test. So do it as soon as possible, so that I will go and collect your test Wednesday, and then I grade it over the weekend because I don't have them. So the next target is your quiz. Quiz number 2. There's going to be sets of assignments that are going to collect it. Everything would be posted, and just prepare for it. That's it for today. Any question? So have a good day, and if you do your test, that's it. Good luck with your test. Bye-bye.
Thank you.
Thank you. Bye-bye.